So the theme this week is the vaccines bring us closer. World Immunization Week 2021, which is from April 24th to 30th, shows us how vaccination will connect us to the people, goals and moments that matter to us most, helping us to improve the health of everyone, everywhere, throughout life. So though physically we are socially distancing and away from each other, but vaccination of our dear people will always bring us closer, improving their health. Right now, you know that vaccines are the raging news, especially Corona, the famous Covishield and Covaxine. Every Tom, Dick and Harry is now educating the other on the merits and demerits of these. So I think actually we can skip that since everybody's so much more educated, and Dr. Kashi may be speaking on something more on vaccine and vaccinology. So with the esteemed Dr. Kashi telling us what is new in the world of vaccine and vaccinology, it gives me deep pleasure to welcome you, sir, who was past president of IAP Bengaluru in 2006 and president of IAP Respiratory Chapter in 2019 to 2020, and he will deliver the lecture today. A warm welcome to you, sir, from Thrissur IAP, and so too to our senior Thrissur IAP member, Dr. Anandakeshwan, Vice President of South Zone 2020. I see that the speaker and the moderator are both mentally very much in tune. Their colors of their dresses are also matching today. Today, I see many senior members here. A warm welcome to each and every one of you. Parvati Madam, past Kerala State President, Purushothaman Sir, Dr. Muralidharan, Dr. Sarojan, Dr. Anju Deepak, Infection Chapter President. To everybody, welcome. So our last month was quite eventful. We had a talk on autism by no other than Dr. Shabina Ahmed, who was the chairman of the autism chapter, and Dr. Maya Bose, who further spoke on the treatment of autism. Members, we are very happy to tell you that we have very exciting meets ahead. The first one is our monthly meet on April 6th. We shall be having a panel discussion on asthma with Dr. Aparna Nambudripad from Jubilee, Dr. Aparna Gulwadi from Amla, and Dr. Nisha Narendran from Government Medical College. We are having a panel discussion, and the apt person, Dr. Krishna Mohan, who is the chairperson of the allergy chapter, he will be the moderator. On May 13th and maybe May 13th, 14th or 12th, 13th, we have not yet decided. We shall be joining Thrissur IAP with the Malanad and Idiki IAP chapters, and we're going to hold a 2-day session on COVID. So it's going to be called as Mission COVID Uday. Please join and please get enriched on how to treat the children of suffering from COVID today. And to end the will be a pediatric endocrinology CME. Dr. Deepa will be further updating us on how we are going to conduct it. So now let us go straight to the talk. I can see here, very happy to see also our past Kerala State President, Dr. Narayanan is also there with you. Warm welcome to you, sir. Dr. Anandakeshwan, shall we go straight?
Yeah, before starting the scientific program, I invite Dr. Narayanan, past State President of IAP, to say a few words in connection with the IAP Immunization Week.
Yeah. Respected President, Dr. Idishanan, Dr. Anandakeshwan, Dr. S.P. Kashi, Dr. Purushothaman sir, and my dear friends in IAP Thrissur and IAP Kerala. It is heartening to note that IAP Thrissur is conducting a program during this World Immunization Week. Other branches are also conducting programs because one action plan of IAP Kerala is bridging the gaps in immunization. And we have been we have organized programs for postgraduate students, pediatricians, ASHA workers, all sections of healthcare workers during this week. Congratulations to the branch for organizing this program. And today's topic is a very interesting one. What is new in immunization of 2021? I think the most interesting thing is that the immunization has moved from pediatrics to geriatrics, because more and more now the vaccination is taken by older people. They are given the priority when it comes to the corona vaccine. So by and large, this will have a definite impact on the in future, because the acceptability of the vaccination will definitely improve, because the whole society is going for vaccination. And we have an expert in this field, Dr. S.D. Kasi, who have been visiting our state every year, many times in a year. So wishing this webinar all success. Thank you.
I invite Dr. Anju Deepak, State President of IIP Chapter, to say a few words.
Thank you, sir. Good evening, Anandakeshwan sir, Kashi sir, Narayanan sir, Reddy madam, Srijit sir, Mukesh sir, and all other senior members and those who have attending online. I'm extremely happy that Thrissur is doing a wonderful program in the infectious diseases with their I Square series. This is the third of the talk with excellent eminent speakers from all over India. I wish all success for the webinar. Thank you, sir.
So thank you. Respected President Dr. Reddy Sandavuma, Secretary Dr. Srijit, Past President of IIP Kerala, Dr. Narayanan, Dr. Parvati Madam, HOD of Department of Pediatrics, Dr. Purushottam Sir, Dr. T.D. Muralidharan, HOD from Palakkad Medical College, Past National Ipv member Dr. Abraham Gepod, Vice President Dr. Mukesh, and EB board member Dr. Nandavuma, Dr. Jagadish Tindappa. So many friends from outside in Kerala also we can see here, because we have an eminent speaker. I think Dr. Kashi Srinivasa Kashi are very familiar to each and every member of IIP Kerala. Regarding immunization, I think it is, as Naran rightly mentioned, it is a right time. People are overthinking about the vaccination. Every day in newspaper and TV, we can see the importance of vaccination. Anyway, even though India is producing very major share of vaccine in the world, and we are exporting vaccine to outside also, but still, only 40% of the people are vaccinated in India. It is a pathetic situation. I am talking about overall all vaccines. It may be due to the fund for the vaccination, the government budget may be low. It may be unawareness of the people, or it may be due to anti-vaccine lobby. I think like any other thing, anti-vaccine lobby also very active in Kerala. It's true. Anyway, we are succeeding eradicating three important diseases. One is smallpox, second is polio, third one is neonatal tetanus. Anyway, this year the theme is vaccine bring people together. I think we are very close together, and I think they talk by. I think all these the Srinivasa Kashis are already introduced by the Reddy Madam. Is very close friend of mine. He was the National Vice President of IIP Respiratory Chapter. He was convener of the Immunization Committee, and also many publications, and also very oration and awards, many awards in his credit. Without wasting much time, I invite Dr. Kashi sir, and also because he readily agreed to accept our invitation. The second thing is actually we used to conduct a program tomorrow, last Thursday, but tomorrow IIP Malnad got another program, vaccinology, where Kashi sir is a speaker. So IIP Malnad requested to prepone our talk. That is why we are here. And that is also readily agreed by Kashi sir. So over to Kashi sir. Thank you very much. Over to Kashi sir.
I just share my screen. Okay. At the outset, I'm really overwhelmed by the affection shown by IIP Thrissur branch. My sincere thanks to the office bearers of IIP Thrissur branch, and of course, Dr. Anand Keshavan sir in particular for giving me the opportunity to take part in the deliberations today. Looking back, the year 2020 has been one of the most exciting years in the field of vaccinology. And a large part of this excitement has been generated by the use of novel platforms for the development of COVID vaccines, the speed of development, the speed of deployment, prioritization, which was never seen before with any other vaccine. So, although people are sort of saturated with COVID-19, I would still like to spend about 50% of my talk on COVID vaccines. New data emerging every day, and I'm going to cover some of the latest data till yesterday evening. I will also briefly discuss the ACVIP 2020 recommendation because that is something of great practical importance. And in the last part, if you all still have the patience to listen, I will also highlight some new vaccines that have entered, not just in India, but other parts of the world, which is creating a lot of ripples in the field of vaccinology. So today, as I told you, COVID vaccines, I will cover many of these other things. Now, why has COVID vaccine generated so much excitement? And as I said, it is mainly because of three factors: the new platforms, the new timelines, and the rapidity at which new data is being generated on a daily basis from all over the world, developed and developing countries. Now, coming to new platforms, we are always, one second, I will just, right, thank you. We are very familiar with the killed or attenuated viruses. We all know these are the oldest vaccines. We are also familiar with the protein vaccines and the subunit vaccines. We are very much used to them. But what we are seeing today are the new platforms like the viral vectors and the genetic vaccines, which are DNA and RNA vaccines. Vaccines which have never been licensed for use in human beings so far are now being given on a mass scale and fairly well accepted by the population in general. Sorry. Now, coming to the first platform, that is a viral vectored vaccine. Basically, what is a viral vector? You take a vector, which in this case is a chimpanzee adenovector. You remove the genes which are responsible for replication. You insert the gene of the spike protein. You get a hybrid virus with the multiplication capacity of the adenovirus, but which can produce the genes of the S protein. This is then injected into the host. A virus enters the nucleus. It takes over the host multiplication mechanism, DNA, RNA mechanism, produces the S proteins, which then comes out into the cytoplasm. And because the S protein is a foreign protein, the body mounts an immune response, both humoral, cellular, and memory cells, and you get a vaccine. We must remember that in case of non-replicating vaccines like the adenovirus vectored vaccines, this virus just enters the cell and cannot multiply anymore. So there is absolute safety with these vaccines. These are not new. You see, the first licensed vaccine, viral vectored vaccine, was the Ebola vaccine, which was called Ervebo by my MSD. Covishield, we know the Sputnik Gamaleya, we know about the Janssen single dose vaccine, AD26, and we also know about the Chinese CanSino adenovector 5 vaccines. What we must remember is that these genes cannot multiply, but you also get replicating viral vaccines, which are also being tried out for COVID today. The main advantage of these viral vectored vaccines is they elicit a very strong both B and T cell response. Because of fairly long experience with the use of these vaccines in the development of HIV vaccines, we know that these vaccines are safe. The only drawback is if there is an pre-existing immunity to adenovectors in the population, it may dampen the immune response. But again, it is also variable. This can be overcome by the prime boost mechanism as the Sputnik is doing, or increasing the amount of antigen in the preparation. And what is of paramount importance is these vaccines can be stored at 2 to 8 and hence are extremely suitable for use in our national immunization program. Next, we come to the nucleic acid, the DNA and the mRNA vaccines. Now, the plasmid DNA cannot be given as such because it will be totally destroyed by the DNases and RNases in the cytoplasm. So you insert it into a protective liposome or a liponucleoprotein particle. This, when injected, is taken up by the antigen presenting cells, enters the cytoplasm. From there, it goes into the nucleus, where the DNA then breaks up into the messenger RNA. This messenger RNA comes out into the cytoplasm, gets attached to the endoplasmic reticulum, giving rise to synthesis of S proteins, which being a foreign protein is thrown out and recognized by the immune competent cells. So remember, a DNA vaccine has to enter the cytoplasm. On the other hand, if we take an RNA vaccine, same way it is enclosed in a liposome for protection from the RNases, it enters the cytoplasm, but it does not have to enter the nucleus. Directly it gets attached to the ribosomes, production of the desired antigen, which in this case is S protein, extrusion from the cytoplasm, recognition by the immune cells, and production of an immune response. So this is the basic difference, is that the cytoplasm is the place where synthesis occurs with mRNA vaccines, and with the DNA vaccines, it has to enter the nucleus and then enter the cytoplasm. The advantages of this platform is it is very easy to produce. You can rapidly scale up production. And in case a variant comes, all you have to do is alter this messenger RNA, insert it back into the liposome, and in a short wait of a few weeks, you can get a new vaccines. There is no mutagenesis because mRNA vaccines don't enter the cytoplasm nucleus at all. But the major drawback is the requirement for very, very stringent cold storage conditions, which is a major drawback. The storage conditions are not available in our country, and hence I think getting these vaccines for mass use in our country is going to be a very, very distant dream. Now, what are the other platforms? We are getting live attenuated vaccines. Remember, all the previous vaccines we were used to is you culture the media under unfavorable conditions and then you attenuate. But today, those days are gone. Live vaccines, live viruses are attenuated by a process called codon deoptimization, where for the production of any protein, you have multiple codon pairs. Some are preferred by the organism, some are not preferred. So what they do is you knock off the preferred ones and then you maintain only the ones which are not preferred. So you get a product which is not the optimum as far as virulence is concerned, and thus you attenuate the organism. And this is the technique by which most of the live attenuated COVID vaccines are being produced. You have replicating virals, you have viralized particles, you have cell-based vaccines. Only one cell-based vaccine is now in clinical trials all over in the world. We have nasal vaccines. We are very excited with it because the nasal vaccine is the one which is going to induce immunity at the site of entry, give rise to sterilizing immunity, prevent asymptomatic transmission, and may have a very, very important role in induction of herd immunity. The next aspect of COVID vaccines is the speed of development. Now, if you see, the traditional vaccine development is a long drawn-out process, and a vaccine takes anywhere from 5 to 10 years, and each process follows the other one. But we don't have the time now for COVID vaccines. So we have an accelerated vaccine development program where they occur in parallel. Once your preclinical studies start showing some favorable results, you parallelly start phase 1. Phase 1 has a 1A and 1B. 1B merges into the phase 2. Phase 2 has a 2B that merges into phase 3. And by the time the initial reports of some Good reports come from phase 2 itself. The infrastructure is created, the manufacturing process takes place. So by the time you finish phase 3, you have approval and the vaccine is ready for distribution. And this is the pace at which COVID vaccines have been developed. Never before in history has this been so rapid. And you can get a picture of this from the sequence of the mRNA vaccines. On 11th January 2020, the Chinese authorities shared the genetic sequence of the novel coronavirus. In 48 hours, they had sequenced the mRNA for the vaccine. In a month and a half, they had developed the vaccine and shipped it for the trials. In another 2 to 3 weeks, the first participant received the vaccine. And on 18th December, less than a year after the gene sequence was released, this vaccine got emergency use authorization. And this is the rapidity. And believe me, this was slow. Further vaccines coming up in an even faster manner. So we're going to see a lot of changes in the way vaccines are being developed and authorized and released for clinical usage. Some little data about the individual vaccines, the new data. Now coming to the Oxford vaccine, let's forget this LDSD. I think it's an aberration. We'll consider the standard dose. The overall vaccine efficacy was about 60.3%. Very poor, or literally no vaccine efficacy against asymptomatic or where the symptoms were unknown. Now, later on, almost about 2 months later, there was a paper which looked into the interval between dosing. And what they found was that if the interval was more than 12 weeks, the vaccine efficacy went up to 81%. And there was some efficacy against asymptomatic infection also. And the vaccine efficacy of a single standard dose after day 22 was close to 76%. And what was very remarkable, there was absolutely no hospitalization in the vaccine group versus 10 in the control group, indicating that this vaccine may be almost 100% effective against preventing deaths due to COVID. Based on this data, the WHO has recommended an interval of 8 to 12 weeks between the doses. In India, the recommendation is 4 to 8 weeks. It was changed over from a strict 4 weeks. And in UK, it is 4 to 12 weeks after the first dose. So this is as far as the interval between doses go. Another thing which has come up very recently is the clotting disorder mechanism induced by the Astrazeneca vaccines. It clinically resembles a condition known as heparin-induced thrombocytopenia that occurs mainly in young women. Basically, in this condition, you have antibodies directed against platelet actor 4, which activates the platelet activating mechanism, causes thrombosis and bleeding disorders both. 11 patients were described from Germany, 4 of whom died. Generally, this condition is characterized by thrombosis at unusual sites, generally occurring between 5 to 14 days after vaccination. Now, this has been reported only with the AstraZeneca and the Johnson & Johnson vaccine. Totally in the world literature, about 62 cases of this central venous sinus thrombosis has been reported, and 44 are from the European Union. German authorities have limited the use of the AstraZeneca vaccine to those over 60 years of age only. The incidence is about 1 or 2 per million. Now, remember, the incidence of VAP following OPV is 3 to 4 per million. The incidence of thromboembolic phenomena after use of oral contraceptives is about 900 to 1100 per million. So if you place it in a proper perspective, this is not any reason to have any hesitation in the use of this particular vaccine. Incidentally, the Johnson & Johnson vaccine, which was paused by the US FDA about 3 days back, they have halted the pause, and now the vaccine is again being used because they have found that probably there is no reason to pause the use of this vaccine in any way. Now coming to the next vaccine that we have, Covaxin, a large phase 3 trial was done with 25,800 volunteers across 22 sites all over the country. The initial interim efficacy data was 81% on basis of 43 cases of COVID. The second interim analysis, which was done after 87 cases, reported an efficacy of 78%. And final analysis will be done when 130 cases have occurred. Unfortunately, there is no published data of any of these interim efficacy data. This has all been reported by the press, and we all know that this vaccine is now being, welcomed with open hands because of the need for the vaccine. The next vaccine which we are going to receive is the Sputnik. And this vaccine has excellent data, which was published in February in the Lancet. This vaccine was ridiculed after phase 2 studies as a hoax by the Western world. And when the publication occurred, they had to eat their own words. It has shown excellent efficacy, 91.9%, over 91% in all the age groups, even in those above 60 years and even in those with comorbidities. And it was found to be a safe vaccine. And the vaccine adverse effect profile was almost similar to any of the other COVID vaccines. So far, we don't have any data about the clotting mechanism disorder with this particular vaccine. I think only usage will tell us whether this also is prone to this vaccine induced thrombotic thrombocytopenic purpura. Now let's come to the new mRNA vaccine, which we probably in India are not going to see. The Pfizer and the Moderna vaccine both were tested in large cohorts. Vaccine efficacy of 94.6% with the Pfizer vaccine, 94.1% with the Moderna vaccine. One dose efficacy about 52.4% with the Pfizer and about 56% with the Moderna vaccine. Good efficacy across all age groups. More reactogenic with the younger age group, more reactogenic with the second dose, and a fairly safe vaccine. The next vaccine which we are going to get is a subunit vaccine by Novavax, which is called NVX-CoV2373. This is a full-length pre-fusion spike protein, which are more stable. It is combined with a plant-based adjuvant known as Matrix MTM, which is trademarked by Novavax. Serum Institute has entered into a collaboration to manufacture this vaccine. In unpublished data, this vaccine has shown an overall efficacy of 89.3%. It has shown an efficacy of 95.6% against the original Wuhan strain, that is the DG614 strain, 85.6% against the UK strain, and about 60% efficacy against the South African strain. Now let's come to the next issue, which is vaccine and variants. I think we are all very, very concerned about this particular issue. We have various variants, and today what we are very concerned is the B1.617 variant, which is the Indian variant, which has spread to over 20 countries today. It is characterized by two crucial mutations in the receptor binding domain. And according to the latest data, more than 60% of the isolates in Maharashtra has this particular double mutation. We don't have data from other parts of the country. There's no reason to suspect why this should not be as common. Now the variants have variable transmission efficacy and also pathogenicity or virulence. Generally, the UK strain has increased transmissibility and very, very little increase in lethality. The South African strain, more transmissible, but is it more lethal? We don't know. Even regarding the Brazil strain and even as far as the Indian strain, it is highly transmissible, but there's no data at present to show that it is more pathogenic or more virulent. So now, how are the vaccines placed as far as the variants are concerned? What are the data available? Now, let's concentrate on vaccines which we are going to use. As far as the Astrazeneca vaccine, which has shown about very good efficacy against the pre-existing variants, it has shown a 74.6% efficacy against the UK variant. There is no data against the Brazilian variant, but very, very poor efficacy against the South African. In fact, it has shown practically negative effect against mild and moderate symptomatic COVID. Novavax has shown definitely a decreased efficacy against the UK variant, but a very minimum, about 20% reduction only, where there is not much data available. And I will come later on to the other vaccines which we are having in our own country. So basically, when you're testing for variants, there are two ways. You take the sera of the vaccinated and you see whether it neutralizes certain pseudovariants, that is, variants of the virus produced in the lab. The other way is to check it in the settings of a trial. We have very little data about this. Now, as far as neutralization of variants with Covaxin is concerned, one study which was published about 2 months back, rather I think in January, where they compared the neutralization activity of the vaccinated individual sera against the UK variant and the local variant, they found a very good similar neutralization activity. And just about a few days back, a study has emerged where they've tested the Covaxin against the B1.617, that is the Indian strain, and it has shown good neutralization. This is a data which has just come about 2 days back. So there is a lot of hope that the vaccinated individuals will be protected or may be protected, or a high chance of being protected against the vaccines that we are using in our country. Now, these COVID vaccines have been in use from December, so it's about 4 months. Now, how well have they worked in the field? This is a data from Scotland, where they found very good efficacy 28 days after giving the vaccine, almost about 91%. And even as far as the Oxford vaccine is concerned, it has shown 88% efficacy, 28 to 34, and going up to higher levels as time progresses since vaccination. Showed very good efficacy in those older individuals. There is another study which has come from England, where they studied the adenovector vaccine efficacy in those above 70 years, symptomatic COVID 60%, more than 35 days 73%, and combined VE against symptomatic COVID and emergency hospitalization to the extent of 80%. As for a very, very good study from Israel, which is one of the first countries to completely immunize the population, has shown very good vaccine efficacy with the Pfizer vaccine. Studies from USA, which has used the Pfizer vaccine, has also shown very good efficacy, adjusted vaccine efficacy, almost about 80% who are partially immunized and 90% against those who are fully immunized, sorry. So indicating that the effectiveness data is almost similar to the efficacy data which were there in the pivotal trials. Do we have any data from India? This is a data released by the Ministry of Health, where they have looked at the number of COVID vaccines doses given and how many have turned positive. And they have found that with Covaxin, where about 1.1 crore doses have given, those who turn out positive after the first dose is about 0.04%. And those who become positive after the second dose is 0.04, similar. And as far as Covishield, it is 0.02% to 0.03%. Please remember, this is positive. This has not analyzed whether asymptomatic, mildly, moderately. It hasn't investigated what happens to severe COVID, death due to COVID, ICU care due to COVID. I think gradually we'll get this data over a period of time. In spite of all this data, there are a lot of unanswered questions. How well is it going to work in the elderly? How long is it going to protect? Are these vaccines safe? We are using genetic vaccines. Unless there's protection from asymptomatic infection, we cannot expect very good herd immunity. What is going to happen against the variants over a period of time? And finally, so much of vaccine hesitancy. How are you going to build up vaccine confidence amongst the population? So with this few comments, I now proceed to the next topic. I'll briefly deal with the ACVIP 2021 recommendations, which were published sometime in January. Now, what were the recommendations as far as polio immunization? A dose of injectable polio vaccine is recommended at 4 to 6 years. Please remember, we were giving oral polio vaccine at 5 years. 2018, it was dropped. Somehow this committee felt that there is a need. We investigated, looked at the literature, were convinced and came out with this data. We also emphasize the importance of IPV in the immunization schedule because many of us are seeing children who have received only liquid pentavalent vaccine and OPV in the private sector and not received any IPV. A uniform dosing of the inactivated influenza vaccine and a change in the schedule as far as the varicella vaccine. Now, let's deal with the injectable polio vaccine. If you look at the waning of immunity after the first booster, there is a marked waning after the primary vaccine. And once you give a booster, it rises up to very high levels. Although the seroprotection does not come down, the antibody titers dip and increase to very high levels after a booster. I'll come to what is the importance of the antibody titers. Now, after giving the second booster in the preschool period, data has shown persistence of very high levels of antibodies at least for 5 years. Beyond 5 years, what happens? We don't know. Now, this small study from Germany looked at what happened to those seroprotection rates in those individuals at 7 to 9 years who did not receive a booster at 4 to 6 years. And you will see here, this are those who did not receive a booster. You will notice that their seroprotection rates had come down to levels of about 90 to 92%, and which shot up once in the population which had received a booster at 4 to 6 years, indicating that yes, that there is a need for the booster. Now, is there any importance correlation between pre-existing antibody titers and internal excretion? Please remember, today in our country, the problem is not paralytic polio. The problem is circulating vaccine-derived polio. And for protection against this particular entity, what you need is a good intestinal immunity. We know intestinal immunity can be of two types. One is a secretory IgA, which is produced locally in the intestine, which is very short-lasting. And secondly, the IgG, which exudes from the serum into the intestinal lumen and also confers some local protection. Now, is there any existence? If there is a correlation, it's worthwhile having very high levels of antibodies in the serum. If there is no correlation, well, giving boosters does not matter. Now, let's look at the data. Some studies have suggested an inverse relation. And this study, which was published in 1969, showed that the association was found to be strongest for type 1 and less for the others. Those with the lowest titers had the highest excretion rate of poliovirus following an oral polio challenge. And those with the highest titers had the lowest excretion rates. Another study where they looked at both the pharyngeal and intestinal secretions also showed that higher the antibody titers, less was the intestinal excretion following an oral polio challenge. Fairly robust data to indicate that yes, pre-existing antibodies do have a role in mucosal immunity as well. And this is one of the major reasons why the present ACVIP decided that it's worthwhile giving a booster. And Plotkin's vaccine, which the Bible mentions that a minimal position would be to recommend 4 to 5 doses of an IPV containing vaccine, with the last one administered at school age entry. Now I come to why has the ACVIP, re-emphasized the importance of IPV. Now the last dose case of wild polio was seen in 1999. 16th April 2016, trivalent became bivalent, type 2 was dropped more than 5 years back. And modeling studies done at that time showed that the vaccine type oral polio, hey, that's nice, someone is drawing on the screen. The vaccine type oral polio will not persist for more than 1 to 1.5 years. So vaccine polio will disappear. But what happened is something very, very surprising. The incidence of CDPV went on increasing. And as of this year, we have more than 1,000 cases of CDPV all over the world. Of course, nothing as far as India is concerned. So the strategy is give MOPV2 to optimate for the outbreaks, strengthen routine immunization, but the more MOPV2, more the seeding in the community. And in fact, this rise has been attributed to the use of MOPV2 for outbreak response. So the new development that is occurring is what is known as the NOPV2 or the novel OPV2. Now, what is this novel OPV2? It is again something that has utilized the codon de-optimization technology, which I just referred to earlier, in modifying the type 2 oral polio so that it becomes less virulent, non-transmissible, and the capacity to undergo reversion is also reduced remarkably in this particular NOPV2. It has been studied in adults and children and has shown good immunogenicity. It has received emergency use listing by the WHO on 13th November 2020, and it is being used as outbreak response vaccine for the next 3 months. And after extensive surveillance, it will probably MOPV2 will disappear and we will be having NOPV2 in the near future. The next recommendation was the Varicella vaccine. The second dose should be administered earlier. Now, the timing of the second dose will depend upon whether it's a primary vaccine failure or a waning immunity. If you have a primary vaccine failure, you have a large number of doses initially, which falls rapidly and then becomes stable. Whereas if you have waning immunity, the breakthrough Varicella will gradually increase with time. Data has shown that the maximum breakthrough thank you. And this vaccine effectiveness study which they did showed that 97% vaccine efficacy in the first year falls to 86% in the second year and remains remarkably stable thereafter. So basically the data is more strong regarding primary vaccine failure rather than waning immunity. And that is the reason why the ACYP recommended the second dose should be given within 3 to 6 months of the first dose and not at 5 to 6 years as recommended earlier. The next major thing that has been done is the inactivated influenza vaccine. We said 0.5 ml, 15 microgram dosage for all. And why did we do this? Because basically, initially, these differential dosing regime was because of the whole cell killed vaccine which were used initially, which caused a lot of febrile reactions, febrile convulsions. So we had a lower dose in infants and a higher dose in those about 3 years. Subsequently, these have been replaced with more purified vaccines. We also know that young children mount a variable immune response to these vaccines, especially against the base strains, which are very important. And recent studies have shown that the 0.5 ml dose will increase the immune response without increasing the reactogenicity. There is data, the Swarovski study, which showed that especially in infants between 6 to 11 months, statistically superior response to H1N1, H3N2, and the H3N2, the B strain, but not much against the H1N1 strain. Another data by Jain and all, which showed that the seroprotection rate, the mean geometric curve were all higher in the double dose group compared to the standard dose group. And based on this, the ACVIP made the recommendations. Now I come to another very, very exciting piece of information regarding the pneumococcal conjugate vaccines. You're all aware that Pneumocell, pardon me for taking trade name, because when I say PCV10, there'll be confusion, which very interestingly has dropped, type 4 and 18C from the PCV10 and included 6A and 19A and made it almost as good as the PCV13. So let's examine what is the data. Now, the phase 3 study was done in Gambia versus Synflorix. And this study showed that, it was non-inferior. That it was non-inferior to Synflorix, both as far as the GMCs and the seroresponse rates were concerned. Even regarding the booster, Pneumocell scored over Synflorix. Post-booster OPA GMTs were higher for Pneumocell for 9 of the 10 serotypes and significantly higher for 7 type. And there was no serotype where the response by Synflorix was higher. Now, this was also compared against PCV13, but here PCV13 scored over Pneumocell as far as the GMTs were concerned. But if you look at the OPA titers, that the functional antibody titers, there is not much of a difference. And if you look at the post-primary IgG, GMC, and OPA, GMC, the actual concentration of the antibodies, it is definitely superior with PCV13 compared to Pneumococcal. There was also phase 3 study done in toddlers, 2 doses in those beyond 12 months of age who were PCV naive. And this was compared to PCV13, both as far as GMCs of the IgG and the OPA was concerned. And as you will see, to some extent, the titers of the IgG antibodies were higher with the PCV13 group, but the functional antibodies were not significantly different. It all depends upon what is the role of the IgG antibodies, what is the role of OPA, is only OPA to be taken into consideration, or are IgG GMCs also important? These are unresolved issues. PCV13 is almost in the final phase of development, which has 22F and 23F added to PCV13. It has completed its studies in healthy older adults and in healthy infants, and will probably enter phase 3 studies very soon. PCV20 contains 7 additional serotypes. One study done in adults over 60 years has shown very good safety data and comparable immunogenicity. And in fact, Pfizer has applied for emergency use authorization for this particular vaccines, not for COVID, but because of the importance of PCV in the COVID era. We all know that Tdap is not a very good vaccine. It wanes very rapidly. So what do? All the pertussis toxin presently in all the vaccines are inactivated by chemical methods, which alters the immunogenicity. So what this very interesting vaccine that is produced by an Asian company from Thailand called Bionet Asia is, they took genetically modified pertussis toxin and made a single component called Pertagen and a Tdap called as Boostagen, which contained, and if you compare it with the existing, a little higher titers of TT-DT. And when they compared this with Adacel, that is the regular Tdap that we are using, look at the titers by Pertagen, Boostagen, and compare it with what is achieved by Adacel. And if you look at the titer at 1 year, there's a very significant drop with both, but far, far higher than Adacel. So Pertagen has received US FDA approval, whereas Boostagen is still in the process. And probably if this comes to India, this will be a very attractive vaccine to use for periodic boosting against pertussis at intervals shorter than 10 years also. Lot of new pertussis vaccines. The BPZA is a nasal vaccine. Phase 1 trials has shown very good activity, and maybe there is a lot of hope as far as this vaccine is concerned. You have whole cell vaccines from which the lipopolysaccharide is removed. You have the outer membrane vesicled vaccines, a lot. One exciting news that has come just last week is a new malaria vaccine, which is actually the CSP, the circumsporozoite protein, tagged to the hepatitis B and surface antigen with a very unique adjuvant called the matrix. And in phase 1, early phase 2 studies, it has shown 74% efficacy and 77%, and which remained almost undiminished in the high dose adjuvant at 1 year. And remember, the vaccine that is presently rolled out, that is the Mosquirix of GSK, has shown only 54% efficacy and rather rapid waning of immunity. So a lot of hope for this particular malaria vaccine. And of course, something we are all waiting for is a universal influenza vaccine. We know the shortcomings of the present seasonal influenza vaccines. So a lot of work, lot of approaches, the HA, hemocretin-directed approaches, the T-cell approaches, vaccines against the neuraminidase, vaccines against the conserved proteins like the M2 proteins, and a very interesting vaccine which has shown good results in phase 1 trials are called this chimeric vaccines. So what happens here? You give the first dose of a regular vaccine, you get a good response to the head antigen and the stock antigens, a good memory cell response also. Now, if you keep on giving the same composition every time, you start getting the same antibodies against the head and very little against the stock. The stock contains the contains the conserved antigens which have broad-based protection. So what they have done is they have made chimeric variants with different head proteins, H8, H5, etc. When you give this in sequence, when you give the second time you give this, you get a very robust response against H8. But since this is common and there's also a memory cell, you start getting a memory response, an animalistic response to H1. When you give a third one with similar stock protein but a different head protein, you get an even more robust response. And this vaccine has shown a very good safety and very high anti-stock antibody titers following 2 doses. And these high titers remained as long as 18 months, something very exciting. Now, RV vaccines, rotavirus vaccines have been in use for almost about 2016 it began. Now, what is the scenario in our country? Has it worked? Is it safe with these extended recommendations, time intervals where they're giving it even till 1 year? Well, we have some unpublished data. These are slides that were presented by Dr. Gagandeep Katkang, which I took, and I would like to acknowledge that this is from her presentation. From 4 places, Rohtak, Tanda, Bhubaneswar, and Tirupati, if you notice, as the uptake of the vaccine increased, the amount of positivity in gastroenteritis stool specimen with RV became less. Overall, those less than 6 months, 54.8 reduction in children hospitalized for gastroenteritis. Okay, general hospitalization. 6 to 11 months, 47.5. 1 to 2 years, 36.2. And a good reduction even in 2 to 5 years. Of course, this is based on data. We don't have any not published. We really don't know what has happened. Safety data has been published in vaccine. And what they have noticed after giving over 4.5 lakh doses of vaccine was that there was no increase in risk of interception, both between 1 and 21 days, 1 and 7 days, or 8 and 21 days. After dose 1, 2, or 3, or all the 3 doses, re-emphasizing the fact that in spite of the extended age recommendations, this vaccine has been shown to be remarkably safe. Okay, why it is so much safer? It may be because the vaccine has been taken too well as in the Western countries. Well, that's a different issue. Friends, we have 5 revolutions in vaccination. Right? We began with the era of attenuation, Jenner. He took the cowpox virus, which was actually an attenuated smallpox virus. Then we entered the era where inactivation of organisms, that is the Pasteurian area. Then came the era of cell cultures. So we got the MMR, we got the chickenpox. Then we entered the phase of genetic engineering. The hepatitis B vaccine, virus vaccine, is the first vaccine which entered the market, which was a consequence of genetic engineering. Subsequently, we started using adjuvants which will skew the response towards a Th1 and give rise to much better vaccines. But now there is so much of explosion of technology that you can literally structure or produce the vaccine antigen according to the best qualities as predicted in silico or by the computers. You can decide how the antigen is going to be displayed. You can control the delivery characteristics. You can control the response in the tissues. You can use painless techniques like the microneedle techniques to make vaccination easier and less painful. You can control the immune cells which will respond. And so many new things are happening that presently with this new technology, we have 258 vaccines in development, not COVID, overall, 125 for infectious disease, 108 vaccines for cancer, 14 vaccines for allergies, 3 vaccines for immune disease, and 2 vaccines for Alzheimer's disease, which have entered phase 3 trials. So with this hopeful note, I end my talk, and I'll be very glad to take any questions now. I may have overshot my time by a few minutes, but I thought this amount of information should definitely be imparted. Thank you very much.
So thank you, sir, for the wonderful, beautiful talk, both on about COVID vaccine and about all other vaccines in IAP and universal schedule of immunization. So we have lots of questions, and also we'll start with my doubt regarding COVID vaccine, sir. So the overall efficacy of COVID vaccines is that 60 to 80%. And in Kerala, we are facing two problems. One is that many of them got COVID infection after 2 doses of vaccine. So my question is that, is there any need for the booster vaccination, booster dose? Of any study like that? It is too early to say, I agree that. Second one is that we are reducing the age. First above 60 years, complication above 45 years, now above 18 years. What about the pediatric study? These are my two questions regarding the COVID.
Okay. So your first thing is about boosters, and the second thing is in children. Now, coming to boosters, following natural infection, studies up to 8 months have shown persistence of protective antibodies and T-cell responses. Now, following the vaccine, maximum follow-up has occurred is for 3 months, which shows persistence of antibodies. We can only get an answer to this question only after long-term follow-up. Incidentally, both Pfizer, Mrna, and our own Covaxin have taken volunteers from their phase 2 studies. They're giving them a booster dose 6 months after they completed the schedule. This is mainly to check what is the immunogenicity and the safety, so that once we get information about the fall in antibody titers and the lessening of protection, then a recommendation for a booster can be made. Right now, it's an open question. No one can answer that. Now, the next part was children. Now, we know that there will be a shortage of the vaccine. So there was a need to prioritize vaccines. So it was given first to healthcare workers because they were at high risk and they were necessary for keeping the COVID management system intact. Okay. Now, next came the elderly population. Though USA says 65, it is country specific, and India has decided above 50 years. The next group was those with comorbid conditions. And now we have come to the 18 to 45 years group. When will children get it? Now, if you look at it, data uniformly, at least till the second wave began, has shown that children rarely get infected. If they get infected, they're usually asymptomatic or mildly symptomatic and rarely require anything more than that. Unlike the influenza vaccine, children have not been found to be a major source of transmission in the community. See, if it was like influenza vaccine, then prioritizing children with vaccination would have been extremely useful for inducing herd protection. Okay, but that is not the case. So for these two reasons, children were not prioritized. All the vaccine trials were done only above 18 years, except the Pfizer vaccine, which has been studied above 16 years. Pfizer has completed a study between 12 and 15 years, where they have shown 100% efficacy in preventing symptomatic RT-PCR positive COVID. And now they are studying it in children between 6 and 12 years and 6 months and 6 years. Mrna also have started their studies in the pediatric age group. So far, there is no data about the Astrazeneca vaccine being studied in the younger age groups. And we all know that the Bharat Biotech has got the DCJ approval for conducting studies in children from 6 months onwards. And I think over a period of time, once we get the safety and efficacy data, only then will the vaccination be open for school children. Remember, in spite of what I said, if we want herd immunity, if we want to cover 70% of the population, children have to be vaccinated. And we can never return to normal unless children are vaccinated. They start going to school. I mean, the amount of mental, emotional trauma, the lack of physical contact, the lack of stimulation that has arisen from COVID is something that is unmeasurable and which really cannot be corrected totally. So it is very essential to protect our children as well.
Welcome to Dr. Venkatesan, our past state president. He already written a question. Sir, you can directly ask questions, sir. Venkatesan, sir. Past state president.
Yeah. You are muted, Dr. Venkatesan.
Venkatesan, sir.
No, he has to unmute. Yeah.
Good evening, sir.
Good evening.
Sir, nasal vaccine, is it available anywhere? And the cost and side effects?
No, nasal vaccine is still just entered the phase of clinical trials. In fact, Bharat Biotech itself is testing 2 nasal vaccines. One is the chimp adenovirus, something akin to our Astrazeneca vaccine, which when given intranasally has been shown to produce a good immune response with fair safety. The second vaccine which Bharat Biotech also is studying is a vaccine which has an influenza vaccine base. It's called the M2SR base of the influenza vaccine, which is a proprietary product of one of the companies. I don't remember the name. So they have inserted the S protein gene into this and looking at a double vaccine, which is going to protect against both influenza and COVID vaccine. The advantages of these vaccines will be sterilizing immunity. It will prevent the attachment of the SARS virus to the nasopharyngeal mucosa and prevent infection and not just the disease. None of them, all of them have just started recruitment for phase 1 trials. It's going to be at least, I think, another 6 months before we see any of these vaccines entering clinical usage.
There's a question from Dr. John. What is the recommendation on pneumococcal booster dose?
Right. I think here I would like to point out that there is a little disparity between the DCGI and the WHO IAP recommendations. There is a robust immune response, booster response, both against Synflorix in the phase 1 study, in the phase 3 study done in Gambia, and in the phase 1-2 study also, which was done in Gambia, where the comparator vaccine was Prevnar. It showed a very good booster response. The WHO in its product insert, has recommended the use of pneumococcal up to the age of 2 years. The ACVIP went into all the data, got some extra data from the company and realized that there is a fairly good, robust data for use as a booster, and hence they made that recommendation. The DCJ has not come out because there are no studies from India regarding the booster. I think it's only a question, and the study is on now. I think it's a question of time. Well, right now, it's a general principle that you don't interchange brands of pneumococcal vaccine. And I don't think the cohort who has received the primary dose will ever reach the stage of getting a booster dose with pneumococcal, at least for a few months. And by then, I think the DCH recommendation also will come. Well, if you're feeling uncomfortable because the DCH recommendation is not there, don't give it in the second year right now. But WHO has recommended it, and you are on safe grounds, and you will be following standard of care if you give the booster in the second year also.
In all the conditions, we are expecting more antibody production following infection rather than vaccination. Here, we are expecting more antibody production following vaccination rather than infection. I think. What is the reason? Another thing is that can we expect any shortage of COVID vaccine? A question by Surendra. And same time, I am asking another question, sir. Because the interval between 2 doses you mentioned about the first it was mentioned 4 weeks, now 2 weeks, 8 weeks, then now in your slide 8 to 12 weeks. Because now the second dose is not available in Kerala, many parts of the Kerala. The people are totally on tension and anxiety. So what is the ideal time between 2 doses? What about the vaccine shortage?
Okay.
And,
I think you have raised 3 issues. One is the antibodies. See, in the vaccines, in the trials, especially in the phase 1 and phase 2, what they looked at was where they compared the antibody titers induced by the vaccines with the antibodies induced in convalescent sera. And they found that in those studies, the titers induced by the vaccines were much higher than those that were present in convalescent sera. Only those vaccines which achieved these milestones went into clinical studies. Okay. Now, in the clinical studies, it was an efficacy study because there is no correlate of protection. Okay. So, doing an antibody titer or saying that because I have higher antibody titers, I may be having higher protection is not absolutely true. So, you don't have to do an antibody titer after taking vaccine also. Okay. So, because there are other mechanisms, T cell mechanisms, which are very, very robust and, which is produced even with the first dose and which persists for a very long time, which may prevent severe disease. So from that point of view, there's no correlate of protection and it doesn't make sense to correlate antibody titers with the efficacy of any vaccine. That is one issue. Shortage is expected. Once the vaccines were released and it was calculated about how many doses, please remember the world's population is about 7.2 billion. That is the population of the world, of which 1.2 billion is in India itself, 1.3 billion is in India. Now, even if you say, about 20% are children who are not eligible for the vaccine. So we are talking of something like about 5.5 billion into 2 doses means 11 billion doses. It was estimated that it is going to take at least 5 to 7 years with the present production capacity to immunize the entire world. Okay. Production capacity will never occur according to what we want. There are many halts. The fire that took place in Serum Institute factory and set back the production by a few months. So from that point of view, shortages are expected. So what best to do when a shortage occurs? First, we know that when you give 1 dose, there is close to 100% protection against severe COVID, death due to COVID, or ICU care due to COVID. That is the first thing. So one school of thought was immunize as much of the population as possible with 1 dose. So at least you reduce the burden on the healthcare system so that hospitalizations due to COVID become less. But on the other hand, if you have a population which is incompletely protected, it may increase the incidence of vaccine variants in the community. That is a real fear about this. Okay, so it's a double-edged weapon. I mean, if you don't have the vaccine, it is always better to give more number of people 1 dose rather than less number of people 2 doses. So that is as far as how to handle the shortage. Now, the third question is regarding the interval. I think, vaccinology is an evolving field. Things change. We have changed so many recommendations. Same way, the first recommendation of 4 weeks came at the end of 3 months of study where the participants data till, I think, 28th December 2020 or something. 2 months later, another publication came looking at the efficacy of 1 dose of the Astra vaccine and the interval. That was there the vaccinees were considered for another 4 weeks or 5 weeks and new data emerged. There was a shortage of vaccine material during the trial. So there were some who got the vaccine after 4 weeks, some who got after 6 weeks, some after 8 weeks, and some after 12 weeks. And when they analyzed, they found that up to 12 weeks interval, the efficacy was much better than 4 weeks or 6 weeks or 8 weeks. But extending beyond 12 weeks really did not make much of a difference. So this new recommendation came. Now, please remember, this recommendation of better is not just antibody titers, it is vaccine efficacy also. So initially the government of India was very adamant. They did not change. In the first meeting, they said, no, we'll stick to 4 weeks. Then I think there was a lot of pressure from the, scientific community within the country and even the ICMR. So they changed the recommendation now to say 6 to 8 weeks. So I think in general, if you have a minimum of 8 weeks, you will be getting a fairly good response. So if there is a shortage, there's no harm in waiting. Wait for 8 weeks or 12 weeks. You are almost practically protected against severe COVID, ICU care due to COVID, and death due to COVID. And I think that is much more than what we really want.
There's a beautiful question by Jagadish Chinnappa, sir.
Yeah.
Sir, is there any role for intradermal administration of COVID vaccine in a trial? Dermal.
Well, there is only one vaccine, the Zydus Vaccine, which is a plasmid DNA vaccine, is being studied, which has already entered phase 3 trials. It is given intradermally in 3 doses over 0, 30, and 56 days. They're looking at only 2 doses between 0 and 30 days. This is the only intradermal vaccine which has reached phase 3 trials. But there, if I remember right, there are at least another half a dozen vaccines, all DNA vaccines, which are being investigated with the intradermal. And here they're using the PharmaJet for intradermal administration, a very remarkable instrument whereby, I mean, you don't require any technical expertise to give the vaccine. You know, I mean, if this really works, it's going to make administration of the vaccine very, very good. And remember, though the DNA vaccine enters the cytoplasm, you know, there can be no insertional mutagenesis. It cannot integrate into the host genome. It cannot multiply indefinitely. All these things have been taken care of as far as the safety is concerned.
And the question by Dr. Devarai Raichu. What is the position of wholesale pertussis vaccine in the background of development of newer vaccine?
What is the status of wholesale
pertussis vaccine in the background of development of newer vaccine?
I think one thing we need to remember that wholesale is a better vaccine. Now, when I say better vaccine means definitely the long-term immune response, if you prime with the wholesale vaccine, is so far superior that the superior, you know, priming persists for decades and decades. So there are studies which shown that those who received wholesale vaccines in infancy, if they receive a booster of acellular vaccines, even 15 to 23 years later, they, you know, mount a much superior memory cell response versus those who are primed with acellular vaccines. Okay. Now, as far as the newer vaccines are concerned, as I said in the talk, we're looking at 2 vaccines. One is making better wholesale vaccines. And one of the main thing is the lipopolysaccharide in the wholesale organism is the one which is causing a lot of problems. So they are genetically modifying the wholesale pertussis organisms to in some way temper down the production of lipopolysaccharide to enable safer and less reactogenic vaccines. Of course, once we come to outer membrane vesicle vaccine, please remember outer membrane vesicle vaccines are the vaccines of the future. That technology is being pursued for many, many conditions, mainly bacterial and some viral infections also. And those vaccines, if suitable, may totally replace wholesale vaccines and the acellular vaccines that are being used presently. I mean, the acellular vaccines, you know, were born not because WCell vaccines were bad vaccines. It became because people are scared of WCell vaccine because of the reactogenicity, because of adverse media and many other reports which came in the press. It was not because WCell wholesale was an inferior vaccine. I think we need to remember that. And somehow everything went on and on and on, and the WP vaccine went into dispute. I mean, but you must not still remember that 80% of the pertussis vaccines in the world as a whole are wholesale vaccine in the NIPs of different countries.
Dr. Nandaguma from Kannur, National Ipv Board member. Nandaguma, you want to ask some questions? One question I had seen there in the chat box. Nandaguma?
Sir.
Yeah.
Sir, that question already answered, sir. Because I asked about pediatric trial. That already answered by sir.
Yeah.
Okay.
Yes.
Now we have an expert, Dr. K.K. Purushothaman,
Yes.
our head of the Department of Pediatrics, and a person very much interested in routine immunization and also good old vaccines. It's not against newer vaccines, but we are all people in favor of good old vaccines. Over to Purushothaman, sir, some comments.
Not an expert, sir. Anyway, sir, about the vector vaccines as such. At present, we are having different platforms, as you said, Novavax is protein, RNA, DNA-based vaccine, and vector vaccines. And what is the future of the vector vaccines? Why? Because coronavirus is likely to mutate over the years, maybe not the frequency of the influenza, but maybe slower. And after 3 years, you may need a totally different vaccine. And when you're using a vector adenovirus, you won't be able to keep pace with this thing. All the genetic vaccines, it's very easy, as you said, within a matter of 6 weeks, you can reintroduce another against that mutation. And if you want to give a booster or to keep pace with the mutation, you can't produce a vector with that speed. So is it a good choice for our country to choose a Covishield and the vector vaccine, or go for the Novavax, which is a better time-tested methodology, and again keep pace, and it's comparatively cheaper compared to the mRNA vaccine? It's not thinkable.
Now, I think there are two aspects to the question that you have asked. One is, was the vector vaccines a good choice for our country? Please remember, as far as our country is concerned, we require a vaccine which is reasonably priced, reasonably effective, and where the cold storage facilities are not too demanding. Okay, and vector vaccines fits the bill very well. The vector vaccine is produced in our own country by Serum Institute, and the government entered into an agreement whereby a certain percentage, rather large percentage, has to come to India. So for all these reasons, the vector vaccines was chosen. And the mRNA vaccines, you know, has been totally cornered by the Western world. Please remember, when the vaccines first came, there was pre-booking of the vaccines, and 13% of the countries pre-booked over 90% of the vaccines, and India was not amongst them. Okay, so I think as far as availability, suitability, I think vector vaccines. The next issue is about modifications of the vaccine, which when variants become more and more common. It is easiest to modify an RNA vaccine or a DNA vaccine, as I said, 6 to 8 weeks. Next is the vectored vaccine, because you take out that S protein which they have, you insert the gene for the new S protein, and you get a vaccine, but it's a little more time consuming compared to the mRNA vaccines. If you come to the subunit and inactivated vaccines, it's going to take a very long time, because the process of development of protein-based vaccines are much longer than mRNA, DNA, and vector-based vaccines. So it will be very difficult to modify Novavax vaccine or the Bharat Biotech inactivated. It will be literally like producing a new vaccine. Whereas for the other two, it is like modification. The process will be much shorter, shortest for the mRNA vaccine, the genetic vaccines, and intermediate for the vector-based vaccines.
So my question was about the adenovirus triggering the immunity, and even in the Oxford study, the half dose followed by the standard dose triggered and gave 92%. The explanation was the first dose triggered immunity, and that's the reason why Sputnik uses 2 strains and all. So in that situation, what is the future? If you need the same thing to be repeated after 6 months, it will be ineffective. That's my question, sir.
To answer this question, pre-existing population immunity definitely has an impact on the immunogenicity of any vector-based vaccines. There are 2 or 3 ways in which they can overcome this. One is the prime boost. Use different adenoviruses for the priming and boosting, which Sputnik has done. The second is you increase the antigen content in the vector-based vaccines.
Yes,
so you get a better immune response. So in that way, the pre-existing immunity against the adenoviruses can be overcome to some extent. But definitely, when you repeatedly vaccinate with the same adenovirus in the same individual, what's going to happen? There is no data. Only time will know when we study it. That's all.
Just one more comment. Time about the nasal vaccine, Dr. Venkatesan asked, and maybe in the coming years, this may be a much, much better choice, because that's going to give the sterilizing immunity, and that's the only answer for the herd immunity, which is very, very unlikely to be achieved by any of these vaccines at present. And why not we give more stress on that?
Definitely. No. See, the stress is it's taking a longer time to produce because it's a new vaccine platform. It's taking a longer time. But I think once the vaccine comes, it will be taken up very well. But of course, we have to be a little cautious. Somehow, if you see, the influenza nasal vaccine has not become popular. You see, we used it for some time and now it's no longer available. Rarely used in the European countries, rarely used in USA, but UK is using it for their childhood immunization program. So I think we have to look at a lot of issues. And I think unless the phase 2 studies are completed, where they study efficacy in a small population, we will never be able to say how good that vaccine will be. But it's an excellent concept.
But what sir said was that Influgen is a company using that influenza plus
right. I couldn't get the name. Right. Thanks. It is Influgen. That strain is called M2SR strain of the influenza, which is the influenza backbone, which is their proprietary. And that has not entered the market still, but they are piggybacking the SARS-CoV virus, inserting it into this Influgen genetic background and trying to produce a double vaccine, which will protect against both influenza and SARS-CoV virus.
And they are bringing up with the rabies vaccines also, I think.
Yes, rabies vaccine, measles vaccine, Newcastle virus. So many vectors are being investigated. And you see, these unusual vectors are good because pre-existing immunity will not be there in the population.
Thank you again.
Thank you.
So, now we have to our past state president, Dr. V.K. Parani, Madam, our retired HOD, very active and enthusiastic student of IIP-Thrissur. Madam.
Hello, madam. How are you?
Nothing. Fine, thank you. It was an excellent talk, nothing to ask, but this nasal vaccine, once it comes, it will be very good for, especially for children.
Yes.
And how long it will take, we don't know. That's the only problem.
Nothing
Excellent
less
talk.
than 6 months, because they're still in phase 1 studies. Recruitment for phase 1 is going on. So it's going to be quite some time, maybe the year end, if the response is good.
Nice hearing from you, sir.
Thank you.
Thank you. Thank you.
Talking about nasal vaccine, we had a talk by Dr. Adam Finn, just I think a few days back, who spoke on influenza. And he was speaking about the influenza vaccine program in UK. And it's a school-based program. The teacher gives the vaccine to the child in the school.
Yes.
After all, what expertise do you need for that? It's going to make vaccine administration very, very simple.
Very easy, simple.
I met Dr. D.D. Muli, the head of the Department of Pediatrics from Palakkad Government Medical College, Palakkad. We give comments. Some unmute, sir.
So it was an excellent talk. I just want to know what pneumococcal vaccine will you advise for older people like us?
Oh, yeah. See, the only licensed vaccine is Prevnar, PCV13. None of the others are licensed. Synflorix is not licensed above the age of 5 years anywhere in the world.
Older geriatric population.
You have to use Prevnar only. Okay, so the schedule is those who are totally naive to pneumococcal vaccine, first take PCV13 and then take the polysaccharide vaccine 6 to 12 months later. But if you are a high-risk individual like diabetes, pulmonary disease, cardiac disease, etc., you can take PCV13 and you can take the PPSV23, that is a polysaccharide vaccine, 8 weeks later also. Okay, so that is the schedule. Prevnar 13 is licensed for use above the age of 50 years in our country. The ACIP, CDC recommends above 65 years, mainly because of insurance issues and not because of anything else. So I think above 50, everyone, especially in the medical profession, should take these vaccines.
Where there is a shift in the serotype, because we are starting from 7, PCV 7, then 13, then 15, 20, 23. Suddenly found out the PCV 10.
No, I see. You can see now, if you see in USA, where the PCV 13 coverage is close to more than 90%, they have found that circulation of PCV 13 serotypes has totally disappeared from the environment. That is why in the elderly, initially the ACIP recommendation of what I just told you, but now the recommendation in 2019 was that only if there is a high risk condition, you use this. Otherwise, give only the polysaccharide vaccine. And there is no additional cost benefit in giving PCV13 as well. Of course, as in our country, this is just not applicable because PCV coverage hardly covers 10% or 15% of the childhood population. There is no question of herd immunity or alteration in the seroepidemiology. I saw Dr. Surendra raise his hand a couple of times. I think.
Yeah. One question I asked you, and another question from Surendra is that is there any problem vaccination in asymptomatic COVID person?
So generally, when you are symptomatic with the illness, you don't take a vaccine against that particular illness or any other vaccine, So one who has had symptomatic COVID, the advice is to take 1 month after resolution of symptoms, not onset, but resolution of symptoms. That is the recommendation. But even those who have had COVID, those who have had even severe COVID or were hospitalized or ventilated need to take the vaccine because we do not know how long the immunity will last after natural COVID.
Is there a contraindication for vaccine for lactating women?
Now, I think this is a very contentious issue. Initially, there was a recommendation that should not be given in pregnancy and lactation, even by the CDC, where they said that if there are other indications for taking the vaccine, then pregnant women and lactating women also should take it. Now, USA has a registry called VSafe, where every woman who has taken the vaccine and either becomes pregnant or was pregnant during the vaccination program has registered herself. They have followed them up. And now they have got a registry of over 90,000 pregnant women. They have analyzed and found that there is absolutely no increased risk of any adverse pregnancy outcomes or outcomes in the infants till 3 months of age. So based on this data, the CDC and even the Royal College of Obstetricians and Gynecologists have said that pregnant women can take the vaccine. Now, as far as lactation is concerned, there is literally no vaccine that is contraindicated during lactation except the yellow fever vaccine. That's the only vaccine which is contraindicated during lactation. So applying the general basic principles of vaccinology, there is no need to, sort of contraindicate vaccination in lactating women. And though the government of India has made this as contraindications, I think you should speak to the individual and decide. If the woman is at high risk and is pregnant, she should take the vaccine because COVID infection itself has a higher morbidity, mortality in pregnancy, which is basically pregnancy is an immunocompromised state. So they need the vaccine a lot. So I don't think we should hesitate in offering the vaccine. And recent studies have shown that women who developed COVID during pregnancy or women who are vaccinated during pregnancy had protective antibodies in the infant also. It is transplacentally transmitted. So I think there are a lot of advantages and I think this should go up. I think government of India will not really make changes so soon at an individual level. We can definitely do it.
Any other questions, Dr. Vijayuma from Pediatrics Vijayuma?
Dr. Anand Kesavan regarding nasal vaccine.
Yes.
What is the question?
The nasal vaccine for the influenza, there were many contraindications.
Yes.
You're not able to give it less than 2 years, immunocompromised, more than some particular age, children who were severe Vs. Will they all be applicable for the nasal COVID vaccine?
Well, no study is to be done, but in fact, when Dr. Adam Finn, when he was discussing the nasal influenza vaccine in the UK National Immunization Program, except those below 2 years and those with immunocompromising conditions, there is no contact. They give it to wheezing children, they give it to asthmatic children and have not found any problems. So we are probably being overcautious because that vaccine was new and we didn't know what it will cause. But I think as far as the indications, contraindication, only time will tell once the studies come. What will be the additional, burden imposed by 2 viruses in your nose? All those things will have to be studied. I really don't have any answer to that question based on science.
You mentioned about IPV at 5 years of age. Is there any study to show that the intradermal vaccination, how much effective in India? How much is your country? Any study there?
1 second. See, you must realize that
You will wind up within 5 minutes, sir. You will wind up within 5 minutes, sir, because there is a good audience.
I'm in no hurry. I'm in no hurry.
Okay.
Now, I'm enjoying this session as much as the listeners, I'm telling you. Now, if you see IPV, the world is moving towards dropping OPV totally. But some protection against polio is necessary, so IPV will continue. So a lot of work is going on in reducing the cost of IPV administration. The first one is the Sabin IPV, which is going to cost about 1/4 of the conventional IPV. It is already entered clinical usage in China and Japan, and probably will enter in other parts of the world also. They have used adjuvanted IPV. And an interesting study has come from Cuba, where they have given 0.1 ml intradermal. I'm sorry, intramuscular instead of intradermal. They are given 0.1 ml intramuscular, 2 doses 2 months apart. And they have compared the seroprotection rates with 2 doses of IM. And they have found that the seroprotection rates are non-inferior. Okay, that means 2 intradermal doses are as good as 2 intramuscular doses as far as achieving the titer of 1:8 is concerned, which is protective against paralytic polio. And that is what is important in today's world. But as I said, as more and more countries have become polio free, what is emerging is protection against CDPV, where the crucial issue is your gut immunity. And for that, this will not work, because there you require much higher antibodies, you require gut immunity. But ultimately, I think the day will come when we are going to use a modified form of IPV for the NIP, and OPV will totally disappear. And once OPV disappears, you are not going to have any CDPV at all. So according to the original strategic game for end game for polio, 2028 was a time when all polio vaccines should have been stopped, but I think we are going to go far beyond that date.
Another question, sir. Can a vaccinated person be a silent carrier of COVID and transmit the disease to family members?
Okay, now a very, very interesting question. Now, if you remember, if you recollect, the CDC recently made changes in its recommendation regarding social interactions with vaccinated individuals. Please remember, they are talking about the Mrna and the Pfizer vaccine, which have 96% efficacy and which has shown fairly good efficacy in preventing asymptomatic transmission also. So they have made the recommendation that for travel, you don't require pre-travel testing. When you land in a new destination, you don't have to show a negative RT-PCR when you land there. Those have received only Pfizer and the Mrna vaccine. They've also said that masking is not necessary amongst people who are vaccinated. Okay. They've also said that masking is not necessary in open spaces. But we are using vaccines which have 60 or 70% efficacy. And now, of course, we have come to the Covax, which is about 78%, and probably the Russian vaccine Sputnik, which is about 96%, 92%, sorry. So I don't think we can make these changes. And presently the recommendation by the government of India and even by the WHO is, even if you're vaccinated and you get exposed, everything has to be done like an unvaccinated person. You have to go into quarantine, you have to test, you have to wear face masks, you should not come into contact with high-risk individuals. All these things are to follow. Whether asymptomatic infection, yes, if you're using Covishield or Covaxin, yes, you can carry the virus and transmit the virus. But not when you're taking the mRNA vaccine, which have 96% efficacy.
So, thank you, sir. It was a very interesting session. And I think today there are 4 programs in Zoom platform in Kerala, but we have very quite means more than 100 because maximum capacity is 100 members to Zoom platform. So today it was very much overwhelmed and overcrowded session today. So I personally thank Dr. Kashi sir for his patience and also for official vote of thanks. I invite Secretary Dr. Sijit Kumar to propose vote of thanks.
Thank you, sir. So we at IIP Thrissur are very delighted and honored to have our Master of Vaccinology today to continue our series of Thrissur Talk series and third in the series. And yes, thank you, sir, for an excellent talk. And it is really a masterclass for in vaccinology and a masterclass from the master. That is summarizing today's talk. We have very senior members of IIP Thrissur joined us, Purushottam sir and Muralidharan sir. And also I thank the Adjuvanted the ID chapter president, Mrna sir, our former past president, and our IIP Thrissur team, Dedimed and Mukesh sir, and finally, and our AK sir is Anandakeshwan sir, who single-handedly organized this Thrissur Talk series. Thank you, sir, for organizing such an excellent program. I hope you to see the next month on last Thursday, and all of this from here. Good night. Thank you.
Thank you, Kashi sir.
Thank you.